Hi everybody. In this video lecture we are going to discuss about function overloading, right? So we will just consider this problem, that is finding gross pay of three types of employee. In Indian Railways, consider our case study of Indian Railways. There are basically three types of employees. One is regular employees who will have three components in their pay, that is basic pay, and then HRA, and then percentage of DA. There will be three components in their pay. But whereas if you consider the second category of employees of daily wages employees, for them there will be two components only. One is the wages per hour and then number of hours that they have worked for that particular week. They will be paid weekly basis, and it is the number of hours they are worked for that particular week. And then the consolidated employees. These are employees who are going to get some fixed pay, right? So there are three kind of employees, and the gross pay is calculated for the employees as follows. That is, for regular employees, this is the formula that we will use: basic plus HRA plus percentage of DA into basic. Similarly, daily wages we will calculate as wages per hour into number of hours. For consolidated employees, we will give just the fixed amount, right? Now we are going to see what is the input and the output. This is the PSC chart where we see that inputs are going to be the components for calculating the gross pay. For each type of employee, it's going to be different, right? And then what we are doing is output is going to be the gross pay. That is what we see. And logic involved is based on the type of employee, we calculate the gross pay using one of the three formulas, right? And we are going to now write functions to find the gross pay, right? What we are going to do is we are going to write three functions, one for each type of employee, but what name we are going to give. Generally, I have also said in the class that the names what we give for the variables and functions must be more meaningful. Then only we ourselves can see the code and understand at later point of time, right? So what I think is, for all the three functions, the most appropriate name would be calculate gross pay. So I am going to give the same name for all the three functions. This is the idea. We cannot give actually the same name for more than one function in the case of C, but in the case of C++ it is possible. How it is possible is, it is by a property, OOP property. It is object-oriented programming property called as polymorphism, right? That is, two things will look alike but they will exhibit different characters. That is the idea of polymorphism, right? What is the meaning of polymorphism? We all know that poly means many and morph means form, right? So there is going to be one interface doing multiple actions. That is what is meant by polymorphism, and it is property of any object-oriented programming language, right? And in C++, polymorphism is supported basically in two ways. One is called static polymorphism, another one is called dynamic polymorphism, right? And when you see static polymorphism, it is implemented in C++ by two ways. One is by overloading the functions and the other one is by overloading the operators, right? So in this session we are going to discuss about overloading functions, right? And when you see polymorphism, it is derived from the Greek word, that is poly, which means many forms, right? And the point is, single name can be used for different purposes, right? This is what I already said: function overloading, operator overloading, and dynamic binding are the three ways by which C++ supports polymorphism, right? And what is meant by overloading is a name having two or more distinct meaning. That is what is meant by overloading. And overloaded function means function having more than one distinct meaning. That is, if more than one function, that is the same function name will have more than one body. The body of the function only says what is the meaning of the function. Okay, so if there is going to be more than one, then we say that as overloaded functions, right? And when we say operator overloading, that is, the same operator is going to have different meanings based on the place where it is used, right? When you see operator overloading, already it is inbuilt in C and C++. For example, we know that minus can be used either as a unary operator or as a binary operator. That is, we will use minus as unary operator for negating a value, that is -2, like that. And also we will use it as a binary operator when we say a minus b, that is for using subtraction. Similarly, star, if you consider star, it is used for multiplication as well as in the pointers also for dereferring and for declaration of pointer variables we use star. Okay, C by itself overload this operator star. And when you see here, this is the insertion and the extraction operators when you see with the context of C in, C out. But in general, they are also shift operators, bitwise shift operators, right? So these operators are also overloaded. And similarly, when you see the arithmetic operators, if you consider plus, minus, multiplication, division, all the operators can work with any type of data, basically numerical data. That is, it can work with integers, it can work with floating point values, and then double values, etc. Right? So arithmetic operators are also by default overloaded for all type of numerical data. Right? So here we are going to discuss about function overloading. Before having a clarity about function overloading, let us understand what is meant by signature of a function. Right? So when we see signature of a function, it is the combination of the function's name and its parameter types in the order. Order is also important. That is when I say int sum of int comma float. This is different from sum of float comma int because the order of the parameters get changed. Right? C++ does something called as name mangling or name decoration, by which though we give the same name in the CPP file, it is automatically converted or changed to some other name based on the signature of the function. That is based on how many parameters are passed and data type of the parameters and order in which it is passed. The name of function is internally converted into some other name. By that only C++ supports polymorphism, or it supports function overloading. That process is called as name mangling. Okay, so the signature is very important. The two functions which is having the same name must be different in their signature, right? That is important, and it cannot differ only by the return type. When we have two functions with the same name, they cannot differ only by their return type. That also must be remembered. For example, consider this function. We have here two functions with the same name, square. Okay, when you see here, the input parameter, both of them take only one parameter. The first square takes one integer parameter and the second square takes one double parameter. They vary the type of the input whatever is taken, right? And when you see the functionality, it's only x into x, but the return type differs, isn't it? This integer, when integer is an input parameter, this square function returns an integer. When double is an input parameter, this function returns a double, right? And in the main, we call square of 7, right? So when a function is called like this, the system will find out what type of parameter is getting passed. Here 7 is an integer, isn't it? So it will take the version of square which takes integer as parameter. So this function will be called and it will print as 49. Whereas if you call here square of 7.5, the system knows that 7.5 is a double value. So it invokes this particular function which takes double as input value and call that, right? This is how it resolves. This is how the system resolves the thing, right? And signature already we have seen, and our given names are not taken into account. So even if I say int a float b and then int x float y, both are same. Only the type of parameters is considered into account when name mangling is done. Okay, so these two functions are same. This compiler will only give an error when we give like this. So this is just a sample code where I'm going to print square. There are 4 versions of the function. One of the version takes an integer parameter, second version takes a character parameter, third one takes a float parameter, and fourth one takes the double parameter. So when you see the definition of the function, if an integer parameter goes, just it is multiplied I into I. When a character parameter goes, it just prints no square for characters. This is what the function does when I pass a character for the function. When it pass the floating point value, it is just saying float and then squares. It is just multiplying and printing. When I say double, it is saying double float and then printing the value. These are the different overloaded versions of the same function, print square, right? Now what will happen is, how the system works is, first of all, when it sees the first name of print square, it just understands that we are defining a function. But when it sees the next function also with the same name, right, print square, then it will think what to do, right? What it does is, it checks the signature of the function. Okay, if the signature is exactly matching the previous function, then it will treat that as an error. Okay, suppose signature of the function matches but only the return type differs, then it will be erroneous. It will be considered as erroneous redeclaration of the function. For example, consider this is a square function which takes one floating point value as input, and this is also another square function, the same name as that of the first one, and it is also taking one float. But when you see the return types, here it is given as float and here it is double. It is not possible to define like this, because during name mangling only the type of parameters and the number of parameters are considered in forming the new name, right? Okay, so if the signature of the function differ in either the number or type of then it is considered as to be overloaded. This is how the system resolves, right? And when we call also, the type is matched accordingly. When I give character as input, then the character version will be called. When I pass this integer as input, then the integer version of the function will be called. When I call this by using a that is double value, the double version will be called. And this, for this version, when I say 12.5f, it understands that this is a floating point value, so floating point version will be called, right? So the steps involved in finding the best match, three things may occur. That is, one match, exactly one match is found for the function call, or no match. This also may happen. Suppose if I call a function which I have not defined at all, then I will encounter no match situation. Ambiguous match, that is, we may find a situation. We will see an example saying what is meant by ambiguous match. For example, for all the cases we will see one example, exact match. That is, there are two functions now with the same name, a function, right? One takes one integer as parameter, this takes a double value as parameter. Now I call a function of 0, right? 0 is an integer, so it will just match this, and this function will be invoked. This is what is exact match. Next is match through promotion, right? Suppose if exact match cannot be found, then the system automatically finds whether there is any definition of function that can be matched through promotion. For example, you consider the same functions, that is, a function with one integer as parameter, another one overloaded version is a function with one floating point value as parameter. Now during the invocation of the function, I give a function of c. Right? C is a character, but there is no function with type character, isn't it? So it cannot make a direct call. So instead what it does is, it automatically promotes this character to integer and invoke this function, a function of int. That is what the system does. This is by promotion, right? Similarly, for example, if you consider the code, right, where I have two square functions, right? One takes integer parameter, another one takes double parameter. When I am calling with 7, this is an integer, so this version will be invoked. This is 7.5, this version will be invoked. But when I give a as the input, what will happen is, there is no data type matching char, isn't it? But automatically this character will be promoted to integer and this function will be called. That is what will happen. You can just take the code and experiment and see. I will pass it to your mails. You can just check by taking the code and experiment. Suppose if I have a separate function, okay, now I have three overloaded version of square. One taking an integer as parameter, another one taking double as parameter, another one taking character as parameter. In this situation, this a will match to char. Since there is an exact match, the system will not do any kind of promotion or anything. It will just make a call to this char version of square when we give like this. This is what will happen, right? And then as a match through the application of standard C++ conversion, that also happens. For example, when I have a function, a function with character as parameter, now I am passing an integer. I don't have a function with integer as, that is taking integer as parameter, isn't it? So what will happen is, now the system will automatically convert this 471 into an integer argument and match this. That is what will happen. Okay, so int argument is converted to character, and we know the 255 is the maximum value that can be assigned for the character. So automatically this overflow will be converted to, whereas it will rotate itself, minus 255 will be computed and that value will be taken. This is how it is. Suppose if I have two versions of functions, a function, one is character, another one is double. Now I passed 471. 471 is an integer value, isn't it? So there is no exact match for 471, but it can be either promoted to double or it can be also called with char, isn't it? So this is a error ambiguous call. The system will not do anything but give an error that there is an ambiguous call for the function. Either we have to provide separate integer, or we have to say by which means this call must be made, right? Otherwise, there is also another one thing, that is match through application of user defined convention. That's what. So when we are going to make a call here, I can explicitly say char. Then that particular character explicit conversion will be considered and this function will be called. And then one more thing we have to discuss when we are talking about function overloading, that is default argument versus overloading. When we are providing default argument, the system automatically also does function overloading. That is, for example, consider this function amount, right, which takes three parameters. First parameter is a normal parameter, float principal, but whereas if you take the other two parameters, they are default arguments. Times equal to 2 and we say float equal to 0.08. Okay, so when we see this function can be either called through all the three parameters, or it can be called with these two, or it can be called with only one. That is also possible. It is sufficient to pass only principal, since other two arguments or default arguments. The value of this will be matched when we don't pass any value for the second and the third argument. See, when I am going to say amount 3000, the function will compute 3000 as principal, with 3000 as principal, and times as 2 and float rate as 0.08. And when I am going to invoke the same function with 3000 comma 4, then the function will use 3000 for amount, principal, and 4 for times, and 0.08 the default value, because we don't pass any value for rate, isn't it? So it will take 0.08 as rate and it will compute. But whereas if we call with all the three arguments, 2500, 5.12, then principal will be considered as 2500, then times will be considered as 5 and rate will be considered as 0.12. Okay, so we can invoke the same function through any of the three things. So what we have to understand here is, when we are providing default argument, then the function is automatically overloaded with some number of parameters based on how many default arguments we give. Now consider our case study. In the beginning of the session, I told that there are three types of employees, and each type of employee will have different pay component and their calculation is also different. Now you consider here there are three functions with the same name, cal, gross, pay. Okay, I am giving the same name, but you see the arguments. This is for a regular employee, for which I pass three parameters. This is basic pay, DA, and then HRA. And this is for the daily wages employee, for which I pass the number of hours they have worked, and then the pay that must be given for 1 hour. And then this is another one function, that is calculate gross pay for consolidated employees. I give a default value for this, right? That is 5000. So this function can be called with 1 or 0 arguments, right? Now this is the main, where I get the option from the user choice, what type of employee he is going to calculate the pay. I permit him to give 4 values. That is, first one means I consider the employee as regular employee. Option 2, I consider the employee as daily wages. Or option 3, they are consolidated employee. Option 4 is consolidated employee with different pay. Right here, I will not pass anything. So I will use this option for finding pay for consolidated employees with default argument. Right. So if the choice is 1, then I declare the 3 variables, get the values from the user, and I call the calculate gross pay function, okay, which is going to calculate the gross pay, right? and then you see here if the choice is 2 given by the user, then we are going to get the values of hours and wages per hour, and then we are going to calculate the gross pay, right? Choice equal to 3, that is the employee is given only 5,000 rupees as consolidated pay. Then I am not going to interact with the user at all. I am just going to return the pay as 5,000. If the choice is 4, then I get the consolidated pay from the user, and then I am going to pass it to the calc gross pay function. Okay, this is the example demonstrating one function overloading in our case, right? These are the implementation of the functions, right? Next, what we are going to see is another example, that is search function can also be implemented in a overloaded version, right? Suppose, for example, when we are trying to book a ticket in the railway reservation system, we do it in two means. One is, if we know the train number, then we can enter the train number and search for it, or else sometimes we also search through the train name, right? So I have created a class railways. I just assume that there are only going to be 10 trains, so I create object for 10 trains, and then num is going to say number of trains, right? And then this is the get function, which is going to get the number of trains from the user, and for each train I am invoking the get function defined inside the train class. This is the meaning, train of I dot get, right? And then search, this search function is going to take the train number as input and is going to return the train name, right? Whereas this search is going to take the train name as input and is going to return the train number, right? So you see, this is the search function. When I pass the number, it is checking with the train number of the class, right? One more thing you must remember, that this class railways must be friend of the train class, then only it can access the private data member. Here we can see that through the object of the train class we access the private data member. Train number belongs to train class, isn't it? We are accessing means we are accessing the private data member. How it is possible is we have to make this class railways as friend of the train class, then only it is possible, right? Now I am checking one by one. This is sequential search, where I search the values one by one. If I have found the train, then I am going to return the name of the train. Otherwise, I am going to return no. This is what the function is going to do. Similarly, another version of the search function which takes the name of the train as input and is going to return the train number. See, since name is a string, we are using the string compare function to find out whether it matches the existing train or not, right? It is equal to 0, then I am going to return the train number, right? This is the main function where I create the object for the railways, and then I get the details from the user, right, about the railways and so on. Here I am calling the search function with with train number, and here I am calling the search function with train name. Hope you have understood better about function overloading. You can experiment the practice problems and see. Thank you.